In the last video / in our last class, we talked about solving systems equations by graphing. Today we're going to talk about a different way to solve equations, and that's called substitution. So by the end of this video, you should be able to solve systems of equations by using substitution. Substitution is exactly what it sounds like. It means we're going to sub certain things in for our variables. So if you look at example 1a, we're going to solve this by using substitution. So here is my system of equations. I have y equals 4x minus 6, and I have 5x plus 3y equals -1. You'll notice that the y is already all by itself. This y is all by itself. So what I'm going to do is, I know that y equals 4x minus 6. I'm going to do this in blue so that we're all on the same page. I know that y equals 4x minus 6, so I'm actually going to plug in 4x minus 6 in for y in the second equation. So what happens then is, if I copy down this second equation, I have 5x plus 3. I'm going to do this in blue again so that we're all on the same page. Oops. Let me X out of those. Sorry, y'all. There we go. So in for that y, I'm going to put 4x minus 6 in parentheses. So now I've replaced this y with 4x minus 6. So then, I'll only do the colors this first time. I know it takes time, but it makes it visually good. So I set that equal to -1. So all I've done is taken out that y and stuck in 4x minus 6 in its place. So I'm going to simplify it. You'll notice that we only have one variable now. There's an x here and there's an x here. So I want to solve for that x. That's my goal. So first of all, I'm going to distribute that 3 through to my parentheses. I've got to solve for that x. So that's my first step. So I have 5x. 3 times 4x gives me 12x. So I add 12x. And then 3 times -6 gives me -18. Equals -1 then. All right, I have some like terms I can combine. You notice here I have 5x plus 12x. Those are like terms. I'm going to go ahead and combine those. Make sure it's the right thickness. So 5x plus 12x gives me 17x because 5 plus 12 is 17. Minus 18 equals -1. So now I have a two-step equation. We're pretty good at these at this point. I'm going to get that x by itself. So first of all, got to get over the thing that's least attached to the x, which is that -18. So I'm going to add 18 to both sides. So I end up with 17x equals -1 plus 18 gives me 17. Now to get x by itself, I'm going to divide by 17 on both sides. I'm left with just x over here. 17 divided by 17 is just 1. Okay, so now I've solved for what x is, but now I got to figure out what y is. So at this point, I'm actually going to plug this back in for x in one of the equations. I would pick this one on top because I'm going to pick y equals 4x minus 6 because the y is already by itself. That's what I'm going to try to figure out. So I have y equals 4 times 1 minus 6. I plugged in 1 for x. 4 times 1 is 4. So I have y equals 4 minus 6. 4 minus 6 is -2. So now I've solved for y. So my answer here is x equals 1 and y equals -2. There's my answer. So I'm going to do the same thing on 1b. You'll notice in that second equation here, in y equals 3x plus 10, The y is already by itself. So I'm going to plug in 3x plus 10 in for that y. So I have 2x plus 5 times 3x plus 10. I took that y out and stuck 3x plus 10 in its place. And that equals -1. So again, I want to get x by itself. My first step to do that is going to be distributing that 5. So I have 2x plus 5 times 3x gives me 15x. 5 times 10 gives me 50 equals -1. I have like terms here. 2x plus 15x gives me 17x plus 50 equals -1. So I'm going to subtract 50 from both sides. On the left-hand side then, since this 50 minus 50 cancels, I have 17x equals -51. So now my next step is I want to get x by itself. So I'm going to divide both sides by 17. Divide both sides by 17. And that tells me that x, if you plug that into your calculator, you'd find that x equals -3. So my x value is -3. So now, don't forget, I've solved for what x is, but I still got to plug this back into one of the equations. I'm going to plug it into this equation because the y is already by itself. So now I have y equals 3 times -3 plus 10. I multiply first, so I'm using PEMDAS. 3 times -3 gives me -9 plus 10. What is -9 plus 10? Well, that's -1. So now I've solved for x and y, so my answer is x equals -3, y equals -1. There is my answer. All right, so now in example 2, we're going to solve and then substitute. You'll notice that a little bit different here. The y is not already by itself. This is y minus 3x equals -13, and the other equation looks a lot like the equations in example 1. So before I do anything, I gotta solve for this y. Oops, clicked off my pen somehow. I gotta solve for this y. So I want to get y by itself. So to do that, I'm gonna add 3x to both sides in that in the second equation. So I get y equals 3x minus 13. Okay, so now I have y by itself. Now I'm going to solve for x by plugging 3x minus 13 in for y in that first equation, in this equation. So now I have 4x plus 5 times, I'm going to plug in 3x minus 13 here, equals 11. So I took this y out and I put 3x minus 13 in its place. So I'm going to distribute that 5x through. I am left with, oops, my bad. I'm left with that 4x out front. 5 times 3x gives me 15x. 5 times -13 gives -65. And set that equal to 11. Again, I have some like terms I can add together. 4x plus 15x gives me 19x. Minus 65 equals 11. I need to get that x by itself, so I'm going to add 65 to both sides. So I'm left with 19x equals 76. So now my last step is I'm going to divide by 19 in order to get that x by itself. So 19 over 19 cancels out. And when I divide 76 by 19, you get 4. So now I know that x equals 4. So now I'm going to plug in that x equals 4 back into this equation. In this equation, I already have y by itself, so that'll be the easiest way to solve it. So I have y equals 3 times 4 minus 13. And I have y equals 3 times 4 gives me 12 minus 13. If I solve out 12 minus 13, you should get -1. So my answer then is x equals 4 and y equals -1. There's my answer to that one. We are going to do this one in class, so hang tight. We'll go ahead and skip to the back. All right, so also when we solve systems of equations, you can get special solutions such as no solution or infinitely many solutions. So let's go ahead and solve this one like we would on the first page. I'm going to plug in 2x minus 3 in for the y in the first equation. So I have 2x minus, I'm going to plug in 2x minus 3 in for y equals 8. So there's a minus sign in front of that parentheses. That means I have to distribute that negative through my parentheses. So I have 2x minus 2x, and then minus a negative 3 gives me plus 3 equals 8. 2x minus 2x, that's just 0. Those actually cancel out. So now you're left with 3 equals 8. Should raise your eyebrows at that. This is not true. And when you end up with an untrue statement, that means your answer is no solution. So if it's untrue, no solution. All right, did the no solution one. Now we're going to solve this other one. We have y equals 2x plus 1 and 8x minus 4y equals -4. So if y equals 2x plus 1, I'm going to plug that in for y in the second equation. So I have 8x minus 4 times 2x plus 1. I took out y and stuck 2x plus 1 in its place equals -4. My first order of business is I got to distribute that -4. So I have 8x, -4 times 2x gives me -8x. -4 times 1 gives me -4 equals -4. All right, so 8x minus 8x, that cancels out. That's just 0. Now I'm left with -4 equals -4. This is true. -4 does equal -4. When you end up with a true statement, it means you have infinite solutions. Earlier when we learned about this, we also called it an identity, and you are also welcome to call it that as well. So we call that infinite solutions. These lines would be parallel, or excuse me, not parallel, they would line up with themselves on the graph, like we learned in section 6.1. These on 3A, when it's no solution, that would mean that those lines would be parallel. And we'll talk about that more in class, but just to get you thinking about what these look like graphically. So parallel lined up with itself.